once the class gets over, because we're doing the same chapter, I'll send the notes. Now, the thing here is, in the chapter, predictability is very simple. But what and all should be skipped, told by a college teacher, should not be skipped. I'll tell you what I mean. So they'll tell this one is not important, okay? So they'll be like, do not try to understand the meaning of stress or strain and directly go to the curve is what they tell you. The most, annoying advice that is, because without knowing the meaning, understanding, see, everybody knows only the curve only will come, the graph. Just because you have so much of, trust on that specific curve doesn't mean you ignore all these smaller concepts called as the definitions, and there are 1 mark on numericals. Very, very, very simple these are. Okay. So even they will be asked. You just cannot tell, just because it is not there in the so-called syllabus, you don't expect them to come in your exams. All those things is bullshit. Fine. So make sure you don't skip those easier ones is the bottom line. 1 minute, wait, I'm finding the chapter. See, now talking about this chapter, after this chapter, there'll be something called as fluids. That actually is a difficult chapter, because that involves a lot of application in daily life, and it is not that simple. Fine. But solids, what I would do is, if you actually focus for like 1 hour, okay, properly in the chapter, you will be able to finish off the thing. It's just that you require help in, what do you call, the graph part of it. Apart from that, everything else is simple. Where is this document? Yeah, got it. Mechanical properties of solids. Of solids. Now understand, the first concept which is supposed to learn is something called as elasticity. Elasticity. Best example, more than trying to use a textbook definition or whatever, use a rubber band example. Rubber band example is the best of among them. So right now, get used to the language what I'm trying to use right now. Assume a rubber band. It is initially not under any influence. So this is the original state of the rubber band. Now, what I'll do, I'll convert this rubber band like this. Now what happened is this is called as an expanded state. Expanded state. Now, this happened because you applied force. The moment you stop applying force, what happens? From the expanded state, the rubber band comes back to its original state. This transformation from expanded state to original state on removal of force is called as elasticity or elastic nature of the rubber band. Getting it? So will this work for clay? Clay example will not work. I'll tell you. Take a cylinder of clay. Okay, you apply some force, make it into a ball. Now, the moment you stop applying force, will the ball turn into the cylinder again? No. Because it is not elastic in nature. Now, let's say you apply force on this ball again, clay ball again, it might become a cylinder because you're trying to apply force. My whole concept of elasticity is on removal of force, the expanded state or the change state, this can also be called as a change state. The change state should go back to its original state. If this is not happening on its own, then the material is not said to be elastic in nature. You should not require an external help here. You should take off the external help called as force, and you should be able to get converted from an expanded state to its original form. So this concept is called as elasticity or elastic nature. Rubber is the very good example. Apart from rubber, a lot of other examples are there, but rubber band is the best example what you guys can think over. Okay. The reason I would not give any other example is because all the other materials will be elastic under few conditions. Rubber band is the only place which is elastic in almost all the conditions. Like whatever the temperature might be, whatever the pressure might be, because we are not trying to experiment the elasticity of rubber band in some lab. We are trying to do it in everyday life. That's how it works. Okay. Now, people used to, okay, fine. I don't think that controversial example is required. We'll stick out to the rubber band example. That's the meaning of elasticity. Next, we'll have to talk something about something called as stress. I think the reason, you won't feel the concept to be difficult because I'll give you an example. Wait. In 9th standard, you learned something called as pressure. Okay. Now, the moment you were learning pressure in 9th standard, you would have also understood the meaning of pressure can be interpreted in many forms. One is mental pressure. One is actually physical pressure, where something is being applied. Let's say something dropped on your feet. That is some amount of force acting on your feet, which is causing you pain. Getting it? For example, when you go to a hospital, that syringe example, where they try to inject you with something, that's also something called as pressure. So pressure is being related almost everywhere. In your first PUC, you'll be learning the concept of pressure, but under a different name called as stress. Now, in ninth standard, pressure was equal to force per unit area. First PUC, it will be called as stress is equal to force per unit area. Technically speaking, both are the same. There's absolutely zero differences between stress as well as pressure. But in first PUC, avoid using the word pressure at whatever cost. Stick on to the word stress and then get your job done. Fine. Now, what is the SI unit? All those things is is the same as pressure. What do you? I mean, if you ask me, what's the main difference? Why aren't we calling it as pressure? Why are we calling it as stress? Is because in pressure, this force was regular force. In stress, this force has a name. This force is called as restoring force. This is very important. Okay. So in ninth standard, we did not talk about restoring force. In first PUC, we talk about restoring force. So in stress, that F does not mean force, but actually means restoring force. Now, what does restoring force meaning? So you applied some force. The moment you took off the force, the expanded state went back to that OG state. Again, it was trying to restore. It was trying to recoil. The recoil is also one of the words. Fine. So during this change, some kind of force was being exchanged there. That force is called as restoring force. Getting it? So the main difference between stress and pressure is in pressure, we use regular force. In stress, we use something called as a restoring force. That's all. Should we write it? Can't we use for definition, can't we stick on the word force? The answer is no. You should always stick on the word restoring force per unit area. That's done. Next in this chapter, the concept is called as strain. Stress and strain is very, very, very important. And without these two words, the whole chapter will not work. Fine. Now, what is this? Stress and strain? Let's go back to the same example of the rubber band. Initially, okay, fine. I'll read the textbook definition first, and then we'll try to understand what it means. It says, it is the measure of deformation. Okay, you won't have understood. The measure of deformation, or in terms of ratio, change in dimension to the original dimension. I'll go back to the example here. Let's say I take an example of the rubber band. Now here it was, let's say, 4 centimeters. Fine. Here, after expanding, it became 4.6 centimeters. Now, if I ask you what was the change after applying force, the answer is 0.6 centimeters was the change. Getting it? So this change is represented by delta. So I draw triangle. Now, this is the best example for strain. Listen up. Initially, it was 4. You applied some force. That force caused some change. How much was the change? 0.6. So totally, the rubber band expanded and became 4.6 centimeters. This is the story. Strain is nothing but change to the original thing. Getting it? The change was how much? 0.6. What was the original? 4. So this ratio of change in dimension to the original dimension, this ratio is called as strain. That's all. So what is the main use of this? It helps me. It helps me discover what was the measure of deformation. So, for example, deformation meaning this is exactly how the original rubber band was. Once you applied force, it deformed, changed in the formation, or change in state, or change in shape. All these things are called as deformation. Guys, change in state also is called as deformation. Change in shape also is called as deformation. Everything. For example, when let's say when a bone breaks, it tends to create its own shape. It got deformed. Getting it? So deformed always means two things. I mean, can depend on two things. One is change in state or change in shape. Both of them have the same meaning, come under the same concept called as deformation. That how much is it deformed? In your case, the doctor is going to tell you. Like how much has the bone been spoiled or how much has the bone cracked. But here we will tell. Telling how we will tell what was the change compared to the original thing. Originally it was so much, it changed, and the change divided by again this ratio. This ratio is called as strain. And always remember, both of them are nothing but ratios. Observe properly. Stress is also something by something. Strain is also something by something. So both stress and strain are nothing but some sort of ratios in terms of formulas, basically. Fine. Now, how do you define strain? Two ways. One is, again, as I told you, measure of deformation. This is one way of, don't write, but one way of defining it. One more way is, it's the ratio of change in an object to its original dimensions. That's it. I would prefer the second one because you wouldn't have to remember it, separately. Now, obviously, as I told you, the complete chapter is depending on these two words called as stress and strain. There'll 100% be some kind of relation between both these concepts. That relation is given by something called as Hooke's law. Very, very, very important. 100% question this is. Hooke's law. Fine. Hooke's law tells us something. It tells us within elastic limit. Now, by chance, if you want to write your own definition, you will be getting 0 marks. So how do you phrase the definition? You should start off by telling within elastic limits. Within elastic limit. Okay. Stress is directly proportional to strain. Now, what people will ignore, they'll only write from this part. If you do not write within elastic limit, 100% it is wrong. Now, obviously, you'll ask me, sir, what is the actual meaning of elastic limit? Listen up. So it's like, let's imagine your bone. Okay, let's imagine your bone. I'll draw it like a dog bone. It's going to be easier for you to understand. Okay, just imagine this to be your bone. Whatever bone. Let's say it is a thigh bone, also called as femur. Now, you take this can happen in your cricket bat also. I think cricket bat also is an example. Whatever, anything can be an example. Can be an example. Okay, bat we take. So let's say you took a rod. You hit the bat like this. With what force? I am not specifying. Listen, you just tapped the bat like this. Did the bat crack? No. Next. I take the same rod, hit it harder. Did the bat crack? No. Again, next. I take the rod, hit it even more harder. Did the bat crack? No. Fourth time, I apply so much amount of force here, this part of the bat actually cracks. Now, if you ask me, sir, what's the difference between hit 1, hit 2, hit 3, and hit 4? The main difference is, when you hit the bat for the fourth time using the rod, the amount of force, see, you became more stronger, realize that. Force was the highest here. But the bat could not take that amount of force, therefore it reacted. But in 1, 2, and 3, it could bear that amount of force, therefore it did not crack. So the main difference between 1, 2, 3 and 4 is 1, 2, 3, the bat was able to hold itself because it could take care of that force. It could handle that force or handle that pressure or handle that stress applied by the rod. Okay. Fourth time, it could not, it breaks down. Same thing with the bone also. Every time you fall, is there a fracture? No. But one time when you fall with good amount of force, the bone tends to crack little. This crack was because the amount of stress it could not handle. Therefore there was some sort of crack there. Can you control this? No, it depends completely on the bone. Now, the moment it cracked, because it could not handle, that concept is called as fracture point. I hope you remember as to why, I hope you realized why we call it as fracture. The point, for example, 1, 2, 3 is not called fracture point. This is called as fracture point. 4 is called as fracture point. Now, what is 1, 2, 3 called as? 1, 2, 3, all these hits will come under something called as elastic limit, which means, I'll go back to the rubber band example. Let's say you applied some force, it became 4.6. You applied little more force, it became 4.9. You applied little more force, it became 5.3. But you tried to apply little more force, the rubber band broke. It became 2 parts. Now, what does this mean? When you expanded, it became 4.9. When it became 4.9, from 4 to 4.9, when it became, the moment you take off your hand, it will again come back to 4, which means elasticity is still working. Next, from 4 centimeter, I applied a little more force. It became 5.3. The moment I take off my hand, the 5.3 again becomes 4, which means it is still under or following elasticity. The moment we are trying to make it as 5.5, it could not take. Who could not take? The rubber band could not take. So how did that react? It broke. Why could not it take? Because elastic limit was only up to 5.3. Anything above 5.3, you are trying to push it to its extreme. And every time until elastic limit, you push how much ever you want to push. It will handle. The moment it exceeds its limit, it'll crack. Getting it? So 4.6, 4.9, 5.3, all these 3 values, the reason rubber band did not crack and come back to its original position is because all these three values were under something called as elastic limit. Elastic limit meaning elasticity was still active. The moment you exceed this, it'll crack. Crack meaning what point? Fracture point. So in this case, 5.3 was the elastic limit. If you try to get 5.4 or 5.35 also, it will crack. Same thing here. The first hit, second hit, third hit was under elastic limit of the bat. The bat could handle it, did not respond. But fourth one, it cannot. Fracture point hit, it goes off. Same thing with the bone. Same thing with your phone also. Same thing with almost everything. Getting it? Same thing with almost everything. You talk about a skin. So people try to, I mean, let's say you came in contact with a knife and the skin did not cut. That is because your skin could handle that amount of piercing. But a lot of times the skin will cut because the knife was sharp enough to cut the skin into two parts. In other language, the skin could not take it. Simple language. But the best example is either bat, the bone, or the rubber band. Rubber band, you'll be able to understand very simple. Okay. Within elastic limit, everybody, everything in this world will have something called as an elastic limit. I can tell in your own concept, I can tell in a mental concept also. People tell, no, even I tell that, you're testing my patience. Now, what does this mean? Up till one point of time, everybody will be able to handle that amount of stress or, or anger, or let's say BT in my language. But there'll always be one point of time where everything will crack. They'll be like, you do whatever and they'll start reacting. That reacting changes from person to person. I might react in a very, very rude way. You guys might go hit somebody. You guys, or you guys might go beat somebody. All these things, beat yourself. All these things are the ways you are trying to react. I am not asking how you are reacting, but everybody had that limit. Okay. And people also tell, no, you're crossing your limits. That is just that, up till then, I'll take whatever shit you're trying to give me. But apart from that, the moment you cross that, I will lose my shit and give you and react in whatever way possible. But that limit up to where you could take shit is called as elastic limit. And if it does not exceed, everything is joy and fun. The moment it exceeds is where, anger comes into picture. You lose your patience. Your blood pressure increases. This is the biology concept of it. But end of the day, it's the same thing. So this, in our case, was called as fracture point, where we lost our anger and we started reacting on people. Everything will have a elastic limit, even mindset. I mean, just an example I gave you right now. No, so keep all these things in mind. Fine. Now, what does this guy Hook? Hook is the name of a scientist. He told within elastic limit, stress is directly proportional to strain. I told more amount of force you apply, more amount of change will happen. Example, look at the rubber band example. You apply more force. First, it was 4.6. It became 4.9. Now, if you ask me, sir, how can 4.6 become 4.9? Because you applied more amount of force. Didn't it crack? Yeah, it did not crack because it was within elastic limit. Fine. So let's say elastic limit was 5.4. Up to 5.35, I'll be able to go. Fine. So I applied more force from 4.9. It became 5.3. But if you see, initially the centimeters was only 4 centimeters. Again, didn't it crack? No, because elastic limit was 5.4. I can play up till this limit. And whatever I do, the moment it reaches 5.3, if I take off my hand, it comes back to 4 centimeters again. Fine. There's absolutely zero damages happening to the rubber band. But the moment you hit 5.41 or 5.42 for that matter, within no time it will crack because you exceeded something called as elastic limit. So how did you increase the dimensions? By increasing the force. Force is proportional to what concept? Stress concept. The change is proportional to what concept? Strain concept. So that's what they're trying to tell. Within the elastic limit, stress and strain are directly proportional to each other. That's the explanation and the meaning to it. Now, Hooke's law is represented like this. E is equal to stress divided by strain. Very important this is. I mean, don't write. It is there in the notes, but I'm just trying to tell you guys. Pathological how it works. E is nothing but stress by strain. Always stress on top. And always, without stress, strain won't be seen. Remember this. Without a force being applied, you cannot expect any change. This happens in real life also, in physics also. Fine. Now, since we learned about stress and strain, we will have to, what is this E called as? It is called as elasticity. To be more precise, it will be called as modulus of elasticity. Is it important? Very, very, very important. Now, in your syllabus, you guys will have to learn about 3 kinds of modulus. The first modulus will be represented by this letter called as Y, called as Young's modulus. So who is Young? Again, is the name of a person, scientist. Then we're supposed to learn something called as shear modulus or rigidity modulus. G representation, shear or rigidity. Shear, I'll write. There's one more modulus which I'm supposed to learn called as bulk modulus. All 3 are important. Now, all these three modulus, since I'm using the word modulus, it means the left-hand side, which means Young's modulus will also depend on some kind of strain and some kind of stress. Shear also will depend on some kind of stress and strain. Bulk also will depend on some kind of stress or strain. Now, without Hooke's law, all these three kinds of moduli, because plural, will never exist. So without Hooke's law, 1, 2, 3 not existing. Without this, physics only won't exist. That's how it works. Now, let's talk about each one in detail. Let's talk about Y first. What's the meaning of Y? Young's modulus. Young, as I told you, is the name of the scientist. Now, what does this tell me? Again, we understood that any modulus should always have stress on top and strain at the bottom. I will write a similar explanation here. Young here told us one thing. He told the formula is nothing but longitudinal stress divided by longitudinal strain. This is the meaning of it, longitudinal strain. Now, obviously, at this point of time, we know the meaning of stress and strain. Now, what are these new words called as longitudinal stress and longitudinal strain? We're supposed to learn more about this concept. What? Longitudinal stress. Let's learn about them. Longitudinal stress meaning. Think. Longitudinal starts with the letter L. Wherever there is a change in length, getting it? Wherever there's a change in length after applying stress onto the body. Okay, if there's a change in length after applying stress to the body, change. Okay, wait, how do I write this? Change in length. 1 minute, wait. Change in length due to applied stress. Change in length. Okay. Due to stress applied. Due to stress applied is called as longitudinal stress. You should you should talk about the word length. Without the word length, the word longitudinal stress has no meaning to it. Remember this. Now, common sense. What does longitudinal strain meaning? In fact, once you remember the meaning of longitudinal, writing strain is very simple. Why? Length is nothing but delta L divided by L. That's all. Because length is L, no. So, strain meaning change to the original. Correct. Change is nothing but delta. Longitudinal means what? Length. So, change in length divided by original length is called as longitudinal strain. Now, obviously, what happens here is you learn whatever modulus, the what do you call it? Formula for stress will always remain the same. Only the formula for strain will keep on changing. I'll tell you what I mean. So y was equal to longitudinal stress by longitudinal strain. Stress is nothing but F by A. Now, if you ask me, sir, what's the difference between stress and longitudinal stress? Again, I'm telling no. If you're applying stress and only the length of the body is changing, only the length of it, okay, then it's called as, then that specific kind of stress is called as longitudinal stress. Whole thing divided by strain is given by delta L divided by L. Let's go back to 10th standard. Denominator becomes the numerator, and then the formula becomes y is equal to, now it's simple, no, obviously. So it'll become F into L divided by A into delta L. This concept is nothing but Young's modulus. That's all. Very simple this is. So what to remember? Young's modulus always depends on two things. What are they? If you tell stress and strain, wrong. You should be specific. Longitudinal stress and longitudinal strain. Now, what does the word longitudinal mean? It means length, change in length. Now, what does stress mean? When you apply force, if there's a change in length, it is called as longitudinal stress. Similarly, change in length to original length will be called as longitudinal strain. You understood both the concepts. We will apply this into the formula. So y is equal to F by A divided by delta L by L. Apply 10th standard logic. Flip it, you will get the answer for longitudinal stress. So, sorry, Young's modulus done. Now, let's talk about shear modulus, also called as rigidity modulus. Both are important. Now, shear or rigidity, what does it mean? So, let's say, the reason I stick on the word shear is because the first word starts with the letter S. Whichever stress changes the shape of the body. First one was longitudinal, therefore length. Whichever stress changes the shape of the body will be called as shear stress. Fine. So again, G is the representation. The formula will be, 1 minute, wait. Shear stress will be change in shape. How do you write it? Okay, wait, longitudinal strain. Okay, shear stress divided by shear strain. Okay. Shear strain or shearing strain. Both of them are fine. Now again, what does shear stress mean? I told you right now. When the stress changes, okay, change in shape due to stress. Due to stress. This is called as shear. Now, obviously, when, okay, what happens to, how do you write shear strain? SHEAR strain. See, understand one thing. Obviously, let's talk about a cylinder only. Okay. Now, the length remained the same. Let's say you applied some kind of strength, you applied some kind of stress to it. The shape only is changing. When the shape changes, let's say it from here it became like this. Some kind of change is visible for you. It has to be visible. Fine. So that now what happens? That specific thing, that extra change will always be represented by delta x. Remember this. I think this is the only place we're supposed to understand the concept. Mug up the concept. The first one and the last one is simpler. Shear strain, because of the change in shape. No. Shape meaning anything can change. I'll tell you what I mean. The length can change, the volume can change, the area can change. Anything can change. So you never know what is changing. So what you will do, you will write shear strain is equal to delta x. Whatever the change is, divided by length. Okay, it's always the length in this case. Remember, fine. So I'll repeat it. 1 minute. Shear stress again is given by the formula F by A. I'll repeat here. Shear strain is gonna change the shape of the body. The changing the shape of the body mean anything can change. Okay. Yeah. Tell. I switch on the headphone. Talk, Dheeraj.
Taken F by A, it's change in length, no? So
A.
be
Change in length due to what?
due to stress.
Exactly. Without stress, do you think there will be change in length?
No.
So let's say I talk about rod, okay? Rod is 1 meter long. I applied force. It became 1.5 meters long. Nothing else changed. Only the length of it changed, correct?
Yeah.
Because only length changed, it's called as longitudinal stress. That's all.
Yeah, I understood the concepts of the
Huh.
formula part. Since it's length, no, so I thought it would.
Yeah, length. See, I'm talking about length, but how much was the change in length? 0.5. The change in length I'm talking about in strain concept. Getting it?
Okay.
That is being discussed, but not here. In the next concept is being discussed.
Why is that?
Because strain is the one which is going to talk about change.
Oh,
Stress is
so
not going to talk about change.
oh,
Stress is going to talk about who caused the change.
okay, got it.
Getting it? The same thing here also. See here, the shape changed. Okay, just say, let's say, example, some random person fell due to accident. So you will tell this person met with an accident. Do you know which part of his body got affected? No.
No.
Correct. His leg might have been broken, hand might have been broken. So you do not know what broke. Correct.
Yeah.
So because there is that what do you call uncertainty there. Correct.
Yeah.
That's why you write delta x.
Okay.
Getting it? So here you write delta x divided by L because it depends slightly on the previous concept called as Young's modulus. Therefore, you write L. Now you know what to do. You write G
So
as it is.
delta x is area, volume, or length.
Yeah, anything. Okay. So shear stress can be F by A, whole thing divided by delta X divided by L. Now what you will do? F by A, L goes on top divided by delta X. That's it. Simple. Got it? Yeah. Obviously, now, I think the easiest one of all is the bulk modulus. See, concept of, everybody knows as to how the concept of gym works nowadays. Bulk modulus, when you're trying to bulk, what is the simplest of meaning? What is the simplest of meaning? It means you're trying to increase the volume of your body. Simple. So bulk modulus always talks about volume. Now, how do you write the formula for bulk modulus? Common sense. Bulk stress divided by bulk strain. Bulk stress divided by bulk strain. Okay. Now what you'll do? Bulk stress, I'm supposed to define. Bulk stress is nothing but change in volume of the body. I'm sticking on the word volume. Due to whom? Due to stress applied. due to stress applied. Formula here also will be the same, F by A itself. Getting it? Next, we talk about bulk strain. Bulk strain. Now, obviously, volume. Change in volume of the body to its original volume. That is called as bulk strain. Now, bulk modulus, what do? You write bulk modulus. Stress was F by A. Strain was delta V by V. Array. F into V divided by A dot delta V. This is the formula for bulk modulus. Same. Okay. You don't even think over it twice. It's the same thing. Fine. Now, what happens? Think of an example here. Let's talk about a ball. You're applying stress from the outside. Obviously, the ball will compress, no? And the volume is decreasing here. So, usually when you apply force in this bulk modulus case, the volume might decrease. Okay. See, bulking in your gym cases, you're trying to increase the volume. But usually in this case, when you're applying force from outside, the volume might decrease. Therefore, usually we write minus. Okay. Bulk modulus is 90% only minus because you're trying to apply force from the outside and inside it'll start getting compressed. That's all. So these three parts, very, very, very important. Getting it? After this, there's a very small concept called as Poisson's ratio. Don't get confused with the spelling. Very important this is. SSON. Poisson's ratio. I'll tell you how this works. Very simple. Again, ratio is there. And representation of this ratio is nothing but, 1 minute, wait. Like this, sigma. Okay. Now, how do you define it? You define it as ratio of lateral strain. Now I'll explain what it means. Don't worry. Lateral strain divided by longitudinal strain. Now, obviously, you'll ask me a question, sir. Both are strain only, no? Yeah, it is strain only. Fine. I'll tell you what's the meaning of lateral or lateral strain. Lateral always means thickness of the material or the diameter of the material. Always. Longitudinal means change in length, that L. Fine. Lateral means diameter, always diameter or thickness in other language. So right now, you will remember it as sigma is equal to minus. This also is minus, remember. Fine. If there is no minus here, the sigma becomes, let's say there was a plus here. Because of these two smaller values, the final answer might become minus. To avoid getting the final answer as minus, we only put off a minus here. Getting it? So if they ask you what is the meaning of a minus in Poisson's ratio, we are using the negative sign to make the Poisson's ratio positive. That will be your answer. Getting it? So it's like you might get the answer as -2, but because of this minus outside here, minus into minus becomes a plus. No. So I want my final answer to become a plus. The only way to make my final answer as a plus in this case is by making the formula as negative. Remember that. Now, so sigma is equal to lateral strain, as I told you, always talks about thickness or diameter. So you write, again, strain is nothing but change, no? So you write delta D divided by D. Whole thing divided by delta L divided by L. Okay, caps. Delta L divided by L. This is the formula for Poisson's ratio. So where this talks about the thickness of the material and this talks about the length of the material. Both does not mean the same. For example, if you talk about a book, the book has length, the book has width, the book has everything. The book also has thickness. So let's talk about your, let's say 10th standard. Okay, fine. What is the main difference between a 200-page book and the 400-page book? The thickness of it. But the length, the width, everything is the same. So that change in thickness is spoken about in the numerator part here. The length of it is spoken about in the denominator part here. So both of them combined together in the same concept is called as Poisson's ratio. This is what the concept is. Now, after this only, the stress strain curve is there. We'll talk about it a little later, but we'll talk about these smaller concepts now. There's something called as elastic fatigue, elastic hysteresis. All these things will appear in your exams for 1 marker, 2 marker, all these things will come. Fine. Apart from whatever I'm teaching you right now, nothing else will come. Remember this. Fine. So we'll talk about, okay, 2 concepts are important. In that case, I'll repeat them. One is called as elastic hysteresis. I'll tell you what I mean, no worries. Elastic hysteresis, HYSTERESIS, and elastic fatigue. Both of them very important.
Is this chapter like important?
Very important.
So, but then our teacher finished it in 30 minutes, sir.
I know. Even I'll finish up in today's class only.
Yeah, but then you always do, sir. how many marks is this chapter coming for?
I mean, everything in this concept is important.
Yeah.
Ivaga, yeah, in other chapters, out of 10, only 4 may be important, but it is important for us to cover all 10. Getting it?
Yeah.
Here, there are only, let's say, 5 concepts. All 5 are important.
Everything is coming.
Everything will come. But
How many marks
again,
is this?
okay, what hysteresis and fatigue?
No, like the whole chapter.
Full chapter, I think it'll come around, 5 marks is the graph. It'll come for around 8 to 9 marks. Final exam talking about.
Midterms also same thing, no?
I mean, depends because other chapters also there. But yeah, everything will come there. See, whatever I thought, no, everything will come. Nothing
Like,
else.
how will they ask? Like, what?
They might also ask define elasticity. Okay, most easiest, but they won't ask this because elasticity concept has been followed throughout the chapter. No, that's why. Now they might ask you for 2 marker, huh?
What would they ask?
I mean that they won't ask you. This one they won't ask you.
Yeah, sir.
But without this, you can't go to the other ones. No, that's what I'm trying to tell you. So they'll ask you define stress and strain. Okay. Next they'll ask you 100% this one. Define Hooke's law. 100%.
Okay.
Okay. Then they'll ask you again. This is Hooke's law. Based on Hooke's law, they might 1, 2, 3. Out of these 3, there can be 2 types of questions being formed. Either name the 3 types of modulus, 1 question, or define and explain Young's modulus, or shear modulus, or Bulk's modulus. They might ask you this. Getting it? One of them, when they ask you separately, all 3 of them, when they ask you like name the following. Name the following. Next, from this
Like
again.
5 markers.
No.
3.
Yeah. 5 marker in this is the only graph, nothing else.
Okay.
Then they'll ask you define Poisson's ratio. Fine. I think Hooke's law and Poisson's ratio is there in all the questions, all the papers I'm talking about. Hooke's law, Poisson's ratio, everything. Now, this one they'll ask you, basically hysteresis and fatigue is called as losses in elasticity. Losses in elasticity. They'll ask you the same concept. They'll be like, define and explain elastic fatigue and hysteresis. And last, they'll ask you the graph as to explain the stress-strain curve. Stress-strain curve. Draw and explain. This is a 5 marker. For sure.
Will come.
Will come. 100% will come. Yeah. Now, obviously, suppose talk about elastic hysteresis. Fine. I'll read one concept. Basically, I'll tell you what it means. Lagging is called as hysteresis. I'm pretty sure compared to any other batch, your batch will be the easiest to understand lagging because online also was there. Understand the concept here. When the internet is not stable either on my end or your end, you are experiencing a loss. How is that loss? That loss is happening because of the lag. Okay. I am not trying to tell loss of information. Information you are getting, but how fast is it? How is it acting depends on the speed of the internet. That lag can be caused if the internet is not stable. Okay. The same thing with power supply. Now just imagine, I'll take an example of rubber. Rubber is a proper elastic material. That's why we're trying to use rubber bands. Correct? Now it goes like this. Rubber, stress, let's say stress is for rubber, not rubber band, okay, rubber material. I'm talking from that rubber, from the rubber tree. In this case, I am telling you stress is not proportional to strain. Not proportional. I'm telling you this. Now, what does this sentence mean? It means for rubber, strain lags stress. Strain lags stress. So you're applying the force, but the speed at which you're trying to apply the stress, the change you are not seeing in the same speed. Okay, it's like you're working really hard, but that strain, I mean, is not you're not seeing that. Fine. So what happens? That lag of the strain compared to stress is called as elastic hysteresis. That lag cost. Fine. The reason might be different. I'm telling you, see, you can never tell. 100 times the mistake might be on the Zoom people because of the servers, or your internet, or my internet, or your neighbor. I'll tell you how. Your neighbor might come and cut your internet wire, or they might be streaming. Something. So 100 factors are there. But who's experiencing the lag? You or me are experiencing the lag. Fine. Wherever a lag is being caused in an elastic material, that concept is called as an elastic hysteresis. If the lag is not caused, then it is not called as hysteresis. Fine. Remember, hysteresis means lag. Fatigue does not mean lag. People get confused with this. Getting it? So how will you explain this? You will tell for rubber, stress is not proportional to strain, and strain lags stress for rubber. Strain lags stress for rubber. This lag in strain, okay, compared to stress is called as elastic hysteresis. And the representation of hysteresis is always a loop, always. So the answer looks like this. The graph looks like this. Okay, it's always a loop. Therefore, that's all. Getting it? So you're applying one thing, lag is there, and then the other thing does its own concept. So this is the load. This is the extension. Not required in terms of understanding this. Just remember the graph. But hysteresis always means lag. Remember this. Now, fatigue is different. Fatigue, simple language is nothing but temporary loss. I'm not telling permanent, temporary loss. If you do not write the words temporary loss, the answer is wrong. Temporary loss of elastic nature of the body. Elastic nature of the body. Now, why is this happening? I'll tell you. Due to repeated stresses. Due to repeated stresses over long time. I'll give an example of magnet. So if you take a brand new magnet, the magnetism is really strong. You keep dropping it, you keep taking a hammer and hitting it. Okay. Then what happens? After some point of time, it starts becoming a weaker magnet. After some point of time, after hitting little more, it won't attract only. Now what is happening? Isn't it a magnet? It is a magnet. But it has lost its concept of magnetism or attracting materials. Fine. Why? Because you kept on hitting it or hurting it basically for repeated time. Same concept here. Repeat stress meaning you keep hitting it for over a long period of time. After some point of time, it will become very rude. It won't react to anything. So at that point of time, if it is not reacting, it's a temporary loss to your body. No, that's the same thing. So temporary loss of what? Of elastic nature. Fine. Of the body due to what? Repeated stresses over a long time. This concept is called as elastic fatigue. Simple. Getting it? You should not, here there is no loss. Understand? Here there is no loss. There is a lag. Fine? Information will come and meet you. But time. It takes time. Here, it won't reach you because one of us is not reacting. Simple. Getting it? So that's how it works. Now, this obviously, graph is not required for this, basically. They'll ask you this concept, elastic fatigue, define elastic fatigue, important. If you don't write the word temporary loss, the answer is completely wrong. That's all, chapter done. Graph you're supposed to do. Okay, but apart from that, everything else, this is the chapter, nothing else is there. Now let's talk about the graph. Graph, I think understanding the meaning of it is first very important. No writing and all. I'll only draw the graph. I'll explain in my own words. Okay. Then I'll send you the PDF. No, you go through the concept. You will realize as to how to write the graph. Okay. So basically, I'll talk about the graph. Very important in terms of both on understanding and in terms of your exam. So along x-axis always strain, along y-axis always stress. Fine. This is called a stress strain curve. The graph should always go like this. Listen up. It's a straight line first. 1 minute, wait. Okay. Up to one point. Mark one point there. First. So you write over here, you write A. Follow the same instructions while you guys are drawing your graph. Now, from here, slight hump. I won't call it as a curve, slight hump. Fine. So here, you won't write B. You will write C. Getting it? From A to C, the midpoint will be B. Remember this. Once you draw that hump, beginning of the hump is called as A. End of the hump is called as C. Top of the hump is called as B. Okay. Once you reach C, you'll draw a slight hook kind of thing, like a fishing hook. Okay. So full freehand it should be. One second. It should not bend so much. Yeah, perfect. Little, it should rise little, then it should fall. The moment it falls, that point will be D. That's all. So totally we're using 5 letters. O for the origin, A, B, C, D. From O to A, straight line. A to C, hump. Top is B. From C to D, free hand drawing like a fish hook. The point where it drops, that concept is called as D. Now, once you're done with this, don't forget, from C, draw a dotted slant line towards the strain curve. This has to be there. Okay, this has to be there. Now focus. Done. Concept is done. What and all? Okay, obviously arrow mark is required. Arrow mark 1, arrow mark 2. That's it. Don't put many arrow marks. 2 arrow marks are more than enough. I'll write the meaning here. OA is called as the elastic range. Elastic range. Now, reason I'm writing this because explanation I'll do with this only. No, from B, point B is called as the yield point. Now, obviously, don't ask me what is this. I'll tell you. From point C to D, this curve is called as plastic region, plastic behavior. Plastic and elastic are two different things. Plastic behavior. And then it's D, fracture point. Okay, one more thing. See, from C to E, you'll write this, no? OE will write, called as permanent set. This part is called as permanent set. Now, please understand the explanation. Permanent set. First, OA was called as the original, elastic range. See, from O to A, if you see, it's a straight line. Wherever there's a straight line, always use the word linear. Okay, it's a linear graph. Now focus. In a linear graph, what does it mean? From O to A, again, if you see, I'm using elastic range. And within elastic limit, what does Hooke law tell us? That from O to A, stress and strain both are directly proportional, which means more the amount of stress provided, more the amount of strain experienced. Getting it? This is happening from where to where? Only from O to A. Done. That's the meaning of O to A. Here, everything is proper. Hooke's law is being followed from O to A. Now, from A to B, the small, from the hump starting to the hump's maximum. Hump stop is called as. Fine. From A to B. Here, if you see, it is not a straight line. There's a slight curve there, which means from A to B, it is not linear. A to B, non-linear. Wherever I use the word non-linear, common sense, if it is linear, stress was proportional to strain. If it is not linear, 100%, what will happen? You won't experience Hooke's law. What else will happen? Okay. Nothing, it won't break. Okay. From A to B, the moment you take off the force applied, it will come back to its original dimension. For example, just imagine for this 4.1 example. Where is it? Oh, this one. 4.6 is proper. Okay. The moment you hit 4.9, it will still come back to its original place. It won't break, no. So from this 4.6 to 4.9, this extra change was from A to B. Remember that. Okay. It is not linear, correct? It is not 100% efficient from A to B, but it won't break at that point of time. This is called as a concept. Now, the moment it reaches B, as I told you, it is called as yield point or elastic limit. Yield point or elastic limit. So from now onwards, things are not in your control. Okay, things are not in your control, which means the rubber band or the material will stop behaving like a elastic material. It will start behaving differently. Now, how is that differently? Listen, the differently is from B to C because B is the yield point. From O to A, it was linear graph. Stress and strain directly proportional. From A to B, it is non-linear, which means it is not proportional, but still. Guys, I'll tell you example. A to B is like that reserve thing in your fuel, in your petrol, in your bikes. Fuel is got completed, but the bike is still moving. How? There was some amount of fuel left in the reserve tank. No. So based on that, it is still moving. Getting as to how it works. That is happening from A to B. Now, from B to C, what is happening? If you see, actually, there's a dip here from B to C. Like observe properly. Fine. Here, from B to C, stress is 0. You are not applying anything, but strain is not 0. If you can see here, it is almost like a straight line like this. Straight line in a graph means what? Constant. So stress, you are not applying anything. Stress is 0. But strain, because of this trauma here from A to B, again, same bike example, you are going on a flat road, you are at 40, If you stop accelerating, the bike will still move little further without any help because of that momentum. Same concept here. A to B to experience something. No. From B to C, the same momentum will carry it through. Fine. But you are not accelerating anything. You're not applying any force. So from B to C, stress is zero, but strain is not zero. Very, very, very important. Now, the moment it reaches C, this is where, the moment it reaches C, this is where things start to change. Now, understand. From C to D, it is called as plastic behavior. Plastic behavior meaning, understand, you take a plastic water bottle, you bend the plastic water bottle. Let's talk about 10 rupee Bisleri water bottle. Let's say you crush it. The moment you crush it, do you think it will become the same shape as before? No. Why? It was not elastic in nature. It was plastic in nature, which means the moment you start applying stress on something which is plastic, from C to D I'm talking about. Okay. You are applying stress, but the strain is more here. Okay. It will not come back to its original dimension. That's what they're trying to tell you. Fine. You are applying stress, correct. It is changing, correct. But can it come back to its original dimension? No. Where is this happening? From C to D. But the moment it hits D, it is called as fracture point, which means you kept on applying so much amount of stress that the object could not take it. It broke. That breaking is happening at point D. That's all. That's the graph. From O to A, straight line, linear curve. Stress and strain are proportional to each other. From A to B, it is non-linear, but it will still obey the rules. Just like the reserve petrol bunk. From B to C, it is changing. How are you changing? You are not applying stress, but strain is still being formed. Just like the bike which is going on a flat road, even without you accelerating. But from C to D, no more elasticity. Complete plasticity is called as complete plastic behavior, which means you apply stress, but it will change. That also will happen. But will it come back to its original dimensions? It will never come back. Fine. So the rubber band might become a thread. It doesn't care. It is like, I am going to behave like this itself. I will not go back to my original position. Why? It became plastic in nature. Again, it remains plastic here. Guys, the thing about plastic, okay, it is not yet broken. It is still intact. Fine. If you take a bucket, it is still a bucket. It is not become a broken bucket. Fine. You are hitting it, you're doing all sorts of things. It is still a bucket. It is still serving the purpose. But again, there will always be a point where if you hit the bucket really hard, it might break. It might break, it will 100% break. The point where it breaks was because you hit it so hard, which means the stress you applied was really hard, the bucket could not take it. That point is called as a fracture point. Now, from the fracture point, it cannot come back to its original dimension, 100%, because it became 2 parts or 3 parts or 100 parts. This thing is a graph. Any doubt in the graph here? 100% question. And I mean, this is the explanation, basically.
What?
Whatever I told you right now.
Okay. And OA should...
How will you write? I mean, is that what you're trying to ask me?
Yeah, how to write like this?
When I send the notes, no, you'll get to know. So, in the notes, it will be like from O to A. Stress proportional to strain. This they'll give you. From A to B, whatever extent, no, they'll give in terms of 2 lines, 3 lines. Getting it? So there'll be like point D, fracture point, where stress is more and it breaks. They'll explain it. Yeah, that's there in the notes. Tell.
And O to A should be use a scale.
If you use a scale, it's better.
Okay, then
And
after that we shouldn't use a scale.
yeah. So make sure this O to A line is very close to the stress curve. I mean, see, this distance should not be more. Less it should be. Getting it?
Yeah.
And it should look like slant. It should not look like a straight line. It should look like a slant line. That's all. From A to C, hump. From C to D, like a hook, fish hook. And hook, guys, listen up. It should not look like this. Hook should always end further. It should not end behind. It should always end like this. Getting it? Remember that. Don't make that mistake. That's a costly mistake. Any doubt in the meaning of the graph?
C to E?
From where to E?
E to C, C to E.
Okay, you won't call it as C to E, you'll call it as O to E. OE you call it as permanent set.
Okay.
Permanent set is, it won't change any more time. So from here, if you see, it lost its elasticity, no?
Yeah.
At B only, limit it reached.
Yeah.
From B to C, it pushed itself. So you can't expect after C also to behave the same way. So that it realized. Who realized? We realized. So therefore we realized at point C, we draw a line. From now onwards, you will absolutely see zero change. How we expected, you get to know that. Getting it? So in other language, from here the villain arc starts off in film. Getting it? So from till here, you could take everything. So from here, you cannot take. So you expect some permanent change here, which will never happen. Getting it? So you tell till from O to E, this concept, this small thing is what he was very good. From here, the villain arc starts off. That's the meaning of it. Correct?
Yes, sir.
Yeah, that's it. Chapter done. I'll send the notes in another 10 minutes. Yeah, I mean, I'm supposed to upload to the drive and then download. That's why. Okay. Go through it right now. If you spend, I think right now, 45 to 1 hour you spend right now, you'll finish the chapter. Now only. Because it's
Sir?
fresh. Yeah, Faizan, I'm sending.
That binomial theorem only proving if you learn it, enough, or
Yeah.
because there's an exercise in textbook. Solve this using binomial theorem and that
We've done
Pascal's
that already.
triangle and all.
The reason I sent that is because I thought you would have forgotten the derivation. That's why. We've done that. Remember that middle term concept and all. That part is done. Sums I've done. This also I've done. It is just that for you to revise, I sent the video. Getting it? Yeah. Any other notes you wanted? I'll send this chapter right now.
No, sir, only this thing.
Only that. I think Madani asked for conic sections. I that fellow has that chapter leave.
Sir,
Okay.
what should we study today?
Finish this off today, this chapter.
Yeah.
Do chemistry.
What in chemistry?
I think whatever you feel difficult.
Sir,
Yeah.
everything is difficult, sir.
That's what, do it then. You see what is actually difficult for you. But I mean, once you read that, okay, do that do the first some portions.
Okay, by the way, you did that structure of atom, no?
Yeah.
That I didn't understand, sir. Those are long.
Which one?
paras.
Array, don't understand. Read through it.
What then? For
I
example,
say,
I'll do.
you are, for example, Rutherford's pudding model means it looks like a watermelon. Correct? Watermelon and seeds. So if you see flesh is more, seeds are less. That's exactly what Rutherford's pudding model means. So within 2 lines you should write. That's all. What's wrong with you? Don't write the full thing and all.
Okay, well, like you'll tell what's coming also.
That I can't tell because see, according to you, nothing will come.
Then
Fine.
what? Then why should
But there's something. See, because for your first test, no, you have more amount of portions. Therefore, they might not ask this. That being told, like I cannot promise you that nothing will come.
for final exam you're talking about?
Yeah, or the midterm also,
Okay.
because you have many chapters, no, apart from this.
Yeah.
So I don't think so this is that important compared to others. But they might ask you for a 2 marker, 3 marker. You will never know.
They'll anyways be choice, no?
That risk you should take. I won't take. Seriously.
I'll go through.
Hey, Sida, if you're able to understand telling watermelon, what is difficult in that?
Nothing.
Yeah. You read it like a story.
Okay.
That's it.
And the first chapter,
What is that first chapter?
basic concepts.
That you want me to do not? No, I'll do that.
You'll do it.
The recording has stopped.
Sir,
You
you
told you
have
want to
a
do that, no?
mail for maths.
Kare? Notes, math. What do you want in math?
Yeah. Anything.
Why you want maths notes, sir? Do the notebook questions enough.
Now, sir.
Sir, have you completed math portion, sir?
Tell me what are the portions.
I don't know.
Hadan,
Yes, sir.
tell.
Sets, relations, complex numbers, trigonometry, then linear binomial theorem,
Limits.
limits, and sequences and series.
Yeah, limits is left. That's all.
So even relations you haven't done.
One BT I'll give you.
So you actually haven't done relations.
Okay, we'll do then. Fine. Again, I got confused. Second piece I did that then.
Yeah, you told us to practice modulus and all, no?
Adem mar sako.
Yeah, you didn't teach us, no? I didn't do it.
So what is there to teach in modulus function?
Derivatives
Ra?
is all differentiation, no?
What, Hadan?
This derivatives and all is what you taught yesterday, no? That
Yeah. Basic. Array, I'll do that chapter. Don't worry. Limits and derivatives. First principle, second principle I'll do. You'll understand. That chapter in the next class will do off. Wait. Then relation functions, I think the modulus function. Modulus function, what is there to teach there, Adiraj? There's nothing to teach there.
So
All mugging up stuff that
the
is.
whole chapter is there's nothing to teach her.
Whole chapter, there's only functions to teach, not the derivations.
Sir, only the graphs and the range domain and all.
That only is there. This Dheeraj, I don't know. He doesn't know what's happening in college only, I guess.
Sir, what as if you knew, sir?
I got fucking 97.
Okay, but you studied for final exam, studying for midterms.
I 100% knew what was happening in college.
Balls, you know.
Array, for example, I didn't know what is modulus function, but I knew modulus function was there.
Yeah, that even I know it's there, sir.
Why you're asking Faizan then?
When did I ask Faiz?
In the sense, right now I'm telling only that is there. I'm telling no, many more things are there. No, nothing is there apart from that.
Only
Three concepts. No, three concepts. One is graph, one is range, one is domain. Range and domain will be asking the same question. That's all.
do it,
I'll tell you, no, half an hour I'll finish off in class. Half an hour only. Chapter illu adal, ಏನು illu adal chapter. That is a complete second PUC chapter that is.
Okay, sir.
So it's like they didn't want to make second PUC chapter so big, therefore they took two exercises and kept it as first PUC chapter. That's all. Nothing else they did.
Sir, and signum function and modulus function have to do.
Yeah. Hey guys, you got the notes, sir? Check. Fazan, got Fazan?
Yes, sir.
Okay. Fine. So do that thing only. Today finish this off and do the chemistry part. Tomorrow I'll come, I'll do off limits and derivatives. Best it is. Perfect. We'll finish off the maths things then.
Sir, thermodynamic revision.
Chemistry wala?
Yes.
Okay. Fine.
So when you'll give paper?
What paper?
In the sense, paper predictions.
Day after tomorrow we'll do then.
Yeah.
Tomorrow we'll finish off limits and derivatives and this Faizan's this thing.
So do of
Thermodynamics.
chemistry, sir, please.
What is there in chemistry? That's what he's telling Faizan now.
What?
Chemistry only is telling thermodynamics.
Thermodynamics, dude.
No, the paper.
Okay, fine. And then 18, but we'll finish off this tomorrow. Wait, two of them. Get math book and come. Check if it is gonna rain tomorrow also. What's happening?
Who's
Sir,
in
in
college?
Sri Lanka, it's there's a hurricane, it seems.
Sri Lanka.
Yeah.
Why are we getting affected?
You will get affected. What the?
How will I? Geography, man. Anyways. Okay, fine. Finish this off.
Says it's gonna rain, sir.
3 days.
Tomorrow.
Sir, 5 days continuous itself from yesterday.
What?
Yes, sir.
What the fuck? Anyways, ignore. I'll see you tomorrow in class only then.
Yeah. Sir, I would have come today, sir.
I went there that. So basically, no, we'll get affected. Record ಮಾಡಕ್ಕಾಗಲ್ಲ ಅವಾಗ.
Why? Oh, Nihar.
Yeah, okay, that's why. Okay, see you.